Now with some examples for functions which are not polynomials. The first one here, x power 3 plus root x minus 3. Here it is not polynomial function. Why? Here we have square root x, and if you put any negative number under square root, it will be undefined. If we substitute here with negative 2, you will get root negative 2, which is not belong to R, so it will be not undefined in this case. Or by another way, we can say here root x. As you learned before, here you have x power 1 and here 2, so it will be x power half, and we say fractions here not allowed. Another example, x power 2 minus 1 over x. 1 over x here we can write it as x power negative 1, and we say the power should be a natural number, 0, 1, 2, 3 and so on, but here it will be a negative power. So here 1 over x equals x power negative 1, and negative 1 doesn't belong to n. The degree of the polynomial function, as we say before, the highest degree of its variables in the function rule. For example, the first one here we have x power 1 in the first term, and in the second term there is no x, so it will be function of first degree. The second one here we have x power 2 and x power 1, and the third one it's absolute term, that means x power 0. The highest one is x power 2, so it will be of second degree, function of second degree. Okay. Before we finding the degree of the function should be simplified. So here in the first example, the function f of x equal x squared minus x squared minus 1 is the polynomial function of which degree here? First, you should simplify it first. Here you have x power 2 minus x power 2. You can cancel both of them. Now it will be function of x equals 1. So it will be 0 degree. So here it will be 0 degree. So before you find the degree of the polynomial function, you should simplify it first before finding the degree. Now with number 2, the function f of x equal x times x minus 1 all to the power 3 is the polynomial function of which degree? Here you can distribute, if you expand this bracket, here power 3 on x, that means it will be x power 3. If you multiply it by x, you will get x power 4. And this is the highest power if you expand this problem. So it will be of the 4th degree. Now another one here, the function f of x equal x squared minus x minus 1 squared is the polynomial function of degree. Of which degree here? The first, we say we should simplify it before we find the degree. How to simplify this part? I want you to revise something with me. A plus b squared. You take it before in second prep. You can expand this part as a squared plus b squared. This is correct? No, we have a missing term here. You multiply the first by second by 2. It will be positive 2ab. And another one here, a plus a minus b squared. If you factorize it, it will be a squared and b squared. This is the final? No, we have a missing term here. We called it before a middle term. So you will multiply the first by the second by 2, which is negative 2ab. So here you should simplify or expand this bracket first. So it will be here x squared minus open bracket x squared, and here positive 1, then first by second by 2, x by negative 1 by 2, it will be negative 2x. After that you can simplify them together. X squared cancel x squared, and the rest here is 1 minus 2x, negative open bracket 1 minus 2x. So what is the degree now? The degree, the highest power here. The highest power is first degree. Now with example 1, here we have set x which equals 1, 2, 3 and 4, and y equals 0, 2, 4, 6, 8 and 10. The function here, function from x to y. This arrow means the domain is x and the codomain is the set y. Such that f of x equals 2x. This part we called it as the rule of the function. This part, f of x equals 2x, is the rule of the function. The question here, write f as the set of ordered pairs. First, you should write the rule of the function at first. F of x equals 2x. Then we will substitute with the all elements of the domain 1, 2, 3, and 4 in this rule. So here we will put here instead of x, we will put here 1. So to get function of 1, you will put here instead of x, you will put 1 here, and instead of this x, you will put 1. So it will be 2 multiplied by 1, which equals 2. Add the first one here, and instead of x, we put 1, so 2 by 1 equals 2. Then we will substitute with the other element in the domain, which is 2. So we will get function of 2. Function of 2, it will be 2 multiplied by 2, which equals 4. By the same way, you will find function of 3 and function of 4. It will be equals to 6. Then function of 4, it will be equals 2 multiply 4 equals 8. Now here, in this case, we will write this function in the form of ordered pair. Here we have the input here is 1, 2, 3, and 4. We can call them as input 1, 2, 3, 4, the input or the domain, and the output here is 2, 4, 6, and 8, which is called the range. Now to write it here in the form of ordered pairs, we'll write it 1 and 2, 2 and 4, 3 and 6, 4 and 8. Now with another example, here we have a function f of x to x squared minus 5x plus 2. First mention the degree of the function. The degree here is very easy. Here you have x power 2 and x power 1 and positive 2, which is absolute term with 0 degree. Which one of them the highest? Excellent, second degree. This is the first part. Now he asked me to prove that function of 2 equals function of half. I will take the first part and I will substitute with 2 in the rule of the function here. Now I will put here instead of x, I will put 2. Then I will find the value of it. Function of 2 equals, instead of every x here, we will put 2. So the answer will be here equals 0. Then now we will find function of half. So instead of every x here in the rule, we will put half, and the answer also equals 0. Now we can deduce that function of 2 equals function of half. Now with another example, the function f is a function from R to R. That means the domain is the set of real numbers and the codomain is the set of real numbers. The rule of the function here, f of x equals 3 minus 2x, mention the degree of the function. The degree of the function, excellent, it will be of the first degree. Then find function of negative 2, function of 0, function of half. So you will replace every one of them by negative 2 at the first time, then replace x by 0, then replace x by half, and get the value of each one of them. So the answer is first degree. Then you will write the rule of the function. Instead of x, we will put negative 2. Then you will get the answer. It will be equals 7. The second one, instead of x, put 0. And the answer will be equals 3. The last one, function of half. Instead of x, you will put half. 3 minus 2 multiply half. 2 times half equals 1. Then 3 minus 1 equals 2. This is the previous example. We will find the degree. The degree will be here of what? The degree, it will be of second degree. Because here we have the second power of x. Then you will find function of negative 2, function of 0, and function of half by replacing x by negative 2, by 0, and by half. Function of negative 2, negative 2 squared minus 4. It will be 4 minus 4, which equals 0. Then function of 0, it will be 0 squared minus 4. 0 minus 4, it will be negative 4. Then function of half, half squared minus 4. Then it will be equals negative 15 over 4.
تقدر تتابع كل دروسك على تطبيق مدرستنا بلس. مدرستنا المستقبل يبدأ الآن.